This is Mark. In this video, I'm going to do a brief derivation of Vedic mathematics. So if we take a number, let's just suppose we take, we could just take 16 and we're squaring it. So what we can do is we can represent this as 10 plus 6 squared. And then if we let a equal 1 and b equals 6, this translates to a naught plus b squared. And then deconstructing this, so basically if we have a naught plus b squared is just equal to a naught plus b times a naught plus b. So we start with these two components and then the intermediate components and then the endpoints. So basically we start with a squared, a times a, carries the two zeros. And then right here we have AB and then multiplied by AB twice, so that's plus 2AB, and we have 1 0. And then this is plus B squared, and there's no zeros. So if we put this together, let's suppose we have two zeros, we have 1 0, and then we have just a placement right here. Well, right here we have A squared, and then here we have AB. We also have AB twice, and then we have B squared. So what this does is it formulates a square into an inverted triangle, which is based on Pascal's triangle. And then we can also relate this. So if I'm taking, let's say we're doing AB squared, it's just AB times AB. What we're doing is we're multiplying, we start with A squared, and then we have AB multiplied by AB and then twice creates a cross, and then B squared. So this creates, which relates to, which is called the crosswise sutra. But in general, what we do with Vedic mathematics is, so basically we notice how we have, notice how the integer right here is 1, and then we have 2, and then we have 1. So basically this is like the Pascal triangle. You start with, I believe it's like 1, 2, 1, and then it's like 1, 3, 5, 3, something like this. But then basically you start at a point and you keep transversing this in this direction, and it expands in either direction as you increase the number of integers. This is based on two integers, a, b, and so forth. If you have 3 or 4 or 5, it increases. So based on this, you know, if we take any number, what we notice is that, so I'm taking like AB and I'm squaring it. So what you notice is you basically start with A squared, and then you start with B squared, and then you have 2AB, which is in the center. So basically this would be like A squared, and then you have B squared, and then you have 2AB in the center. And this is what creates the triangle. So essentially, if I have 3 units, ABC squared, this relationship doesn't change. The pattern stays the same. It's A squared, B squared, C squared. But now you shift 1 unit to right. It's 2AB. And then you shift. So after I connect these ones, I'm connecting BC. And then at the end, I have 2AC. And so forth. So this creates, notice how it's 3, 2, 1, and 2, 1. So this is based on the number of digits. So yeah, this is just showing a brief introduction to Vedic mathematics. It's an Indian type of method. We in the U.S. we just use a regular multiplication. We can't translate this. This is, you could consider more a quicker way to solve complicated multiples because it's symmetric and so forth. But we're not going to utilize this in the U.S. because, you know, all of our fields are predicated based on the traditional method that we used. But in India, yeah, they use this method, and it's very interesting. But it was originated, I believe, 2,000 years ago. The Chinese came up with the method. They had manuscripts, and I believe 40, 50 years ago, an Indian mathematician developed this. Apparently, I was late. When I was working on my undergrad, I came up with this as well. But I thought it was something new. Of course, it's very difficult to create something new, but it was derived based on this relation right here as this triangle. It's based on the tenths place, and I mean um, I think in anything like math, if you're interested enough, you just try things, you explore, and eventually you come to conclusions. And that's kind of how I did things. But yeah, this is just showing the um, Vedic mathematics, and if anyone's interested, and I hope you enjoyed, and we'll see you next time.